The horizontal position of a particle is given by the equation. They give us the equation there where t is measured in seconds and s in meters. So first of all, part A says find the velocity at time t. Well, we know that the velocity is the derivative of position, or rate of change of position, and so I need to find a derivative to do that. Now, to find the derivative, you can use the definition of derivative, or if you know derivative laws or rules, you can use those. The purpose of this video is not to show you how to find the derivative, but how to use it. So I'm just going to write down the derivative that I got, which was 3t squared minus 12t plus 9. Now, part B says when is the particle at rest? Well, it's at rest if its velocity is 0. And so I'm going to take the velocity and set it equal to 0 and solve it. While I'm doing that, I'm going to factor a 3 out, and I will have t squared minus 4t plus 3. And I'm interested in when that's 0. Well, that'll factor some more. So it'll factor into t and t, -1, -3. So the velocity is 0 at t equal 1 or 3 seconds. Now part C says when is the particle moving forward? That's in the positive direction. So this said it's got horizontal motion, so the particle could be moving forward and backward here. So we're looking for when the velocity is positive. Now in order to answer that, I'm going to make a quick sketch here. And I'm going to draw the graph of the velocity, and the velocity function is right here, and that is a quadratic, so we know it's a parabola. The quadratic term is positive, so we know it opens up, and I know when it equals 0 because I have those 2 points, so those will be the intercepts. It's going to intersect at 1 and at 3, and I know it opened up, so I'm going to go ahead and just do a simple sketch of this velocity function. Didn't worry exactly where to put the vertex because that's not an issue here. The point is when is this positive and when is this negative. It wasn't written here, but we're going to assume that t is greater than or equal to 0. So as I'm saying when is this positive, it's going to be positive here, and it's also going to be positive over here, and if this continues. So if I were to write the intervals where this thing is positive or moving forward, because those mean the same thing then here, it would be moving forward from 0 to 1, and then also from 3 to infinity. Okay, so now we're supposed to draw a diagram to represent the position of the particle. So let's make a diagram. We'll put a number line here, and if we use the position function, which is right up here, at 0, it's 0. So we're going to have this particle start right here, and on the interval from 0 to 1 is positive, so this is moving to the right. So I'm going to find out where it is at 1. And I'm simply plugging 1 in the position function, and it looks like I get 1 minus 6 plus 9, so that looks like that's 4. So what that tells me, 1, 2, 3, 4, tells me in the first second that this particle moved over here to position 4. All right, so next, let's see what happens. Well, looking at this, we see from 1 to 3 that the velocity is negative. That means this thing has to turn and go back the other way. Now, because you can't really see a turn and go back the other way really well, I'm going to put it slightly below. I'm also going to put it in another color. I'll put it in red so we can see. All right, so between 1 and 3, it's going to be going back the other way. So let's find out where it is at 3. So if I put 3 in this function, I have 3 squared, which is 27, minus 54, so that's negative 27, and then putting a 3 in here, plus 27, so it looks like it's at 0. So what actually happened here, and I'm putting it a little bit below so we can see, is it went back here to 0, so it turned and went back this direction. Okay, let's see what is going on with it next. And so the next thing we do is say, okay, from 3, and this says in the first 5 seconds, so we're going to go from 3 to 5. So let's find S of 5. So if I put a 5 in here, I would have 5 cubed minus 6 times 5 squared plus 9 times 5, and it looks like that is 20. So what that says is it turned and it started going back this direction again, and again they're on top of each other, but I'm splitting them so you could see it. But it kept going this time till it got clear over here, which really would probably be off the screen, but to 20. So if we want to know the total distance that it traveled, well, if we saw that it went 4 this direction, and then when it did the red one going back, it was 4 again, and then from there it went over to 20. So it looks like it traveled 28 meters. So the important thing to realize here is if it backtracks, you've got to keep track of that. And how do you find out if it backtracks? Well, you look and see where it's 0 and where it's positive versus where it's negative. And so a diagram is helpful for answering that. Now let's go ahead. We did E. Let's look at F. Find the acceleration of the particle at 4 seconds. Okay, so if we have position and we take another derivative and get the second derivative, that is acceleration. So that's also the derivative of velocity, because we took the first derivative position, we got velocity. We take another derivative of that, so the derivative of velocity, and we would have acceleration. So we need to go to our velocity function and use the definition of derivative or use derivative rules and come up with the derivative of the velocity, and that will be the acceleration. So that's going to be 6t minus 12. And now we can answer the question, what is the acceleration after 4 seconds? Because we could put a 4 in there and we would find the acceleration is 12, and the units are meters per second squared. Time is squared on acceleration.